Right, so welcome to 2168. So first, I just want to mention a couple of irregularities that could happen. The first is that I have jury duty on Thursday, so that means that if you're in the there's most of the times I will try to make it to your labs. This time it's going to be a bit rough for me if I'm trying to make it to your lab on Thursday. On Friday, same. I'll try to make it to your lab, but if I get selected to a jury and it meets on Friday. And if it meets the following week, because I have no idea how these things work, but I know that it's supposed to basically serve pretty much immediately, I believe, in Philadelphia. If for some reason I have to miss Monday and Tuesday's classes, then I have contingencies in place where basically I will upload a video online. It will be your responsibility to watch it. It's going to be maybe a half an hour to an hour long, and then your lecture will be turned into an additional lab, essentially. So your TA will be here, and you'll be tortured on another assignment. I'm sorry, but it's the best. But I'd rather do that than cancel class. You know, I want to make sure you get your money's worth. I explained the syllabus. The big thing to read in the syllabus and watching that video is how your homework gets handled, which is that homeworks and labs are the same thing, and that in order to get a grade, you will have to demo them to us. In other words, show us that they work in order to receive a grade. And I go into detail about that. And if you have any questions about that, you can ask me during the lab. The syllabus also lists kind of uselessly the time and place we meet because you figured that out. So it's kind of useless. But in general, if you need to get in contact with me, email me at andrew.rosen@temple.edu. And I will pretty much be very quick to respond, except for around sundown on Friday evening and sundown on Saturday evening, because I try to avoid doing any work during those. I sometimes fail, but I try to avoid doing work during that period. Okay, so with that, I'm going to jump right in to a review of material from, and let's just see the hotkey work. It worked, awesome. So I'm going to jump right into a review of material from, oh, what are you doing? Why are you doing that? I don't want you to do that. Display settings. It's, yeah, here we go. Duplicate slideshow. It tried to set up the whole presenter view, which is rather silly, where basically it shows me a different view with notes, and I'd rather be reading off the slides. So your textbook is a bit unique for once, which is that you're for once getting a textbook, and we're actually going to go over pretty much every single part of the textbook for once. The only thing that we're probably not going to cover is Chapter 9, and the only reason we're not covering that is because we probably don't have enough time. But we'll go through 1 through 8 and Chapter 10. And Chapter 1 essentially is a review of the object-oriented programming that you guys should have learned in 1068. And I say should have, but of course it was a long break, you know. So I'm going to assume that you could probably use a refresher. So how many of you remember the term inheritance? Right? So a good number of you. Encapsulation. Yeah, kind of rings a bell. Polymorphism. Yeah, okay, but you could definitely use a refresher. Awesome. Okay, so we're going to go over that today. I've got if you were in my class for 1068, this first 15 minutes is going to be a bit of a bore because you got this exact same lecture in 1068. But I find it's a really good example of what of how these things of how inheritance works in Java as well as polymorphism. And the big thing here is that this will be a good way to review Java as well as just make sure that we're all on the same page. Because in order to learn what data structures are in Java, you have to understand how the inheritance works, because we're going to be doing a lot of inheritance when we write our data structures. All right, so we're going to be working on, so I'm not going to be doing too much of the slideshow. I'm just going to breeze through and make sure that there's not anything I'm missing. There's basically two concepts we're going to be learning. Abstract data types, which are basically how do we collect data together. Like, and when I mean data, I mean like individual pieces of data. We're really working on kind of the micro over data, like how does an individual piece of data get stored somewhere? So how do we collect our data and how do we manipulate it? And an abstract data type that really just kind of tells you how to do that. And we use abstract data types as like a definition. An example of this is a list. And I'll go over this again when we actually get to lists. We also need to know how, we want to know how like a list works, so how is stuff collected into a list, and then also how do we manipulate a list. And when we use these abstract data types to actually write data structures. We aren't going to be directly working with abstract data types. They're kind of just the specification, the theoretical kind of thing. So think of it as abstract data type as being the theory and the data structure being the implementation of how we do it. So how many of you remember interfaces? How many of you, was anybody not taught interfaces is a better question. Interface. Okay, so one of you, couple of fearful looks, couple of yes, no, maybe looks. So we'll go over interfaces as well. Interfaces are kind of like really abstract classes. Does that ring a bell at all? No? Okay, so for some of you that does. So let's go ahead and get started with our examples then. So, all right, first things first, let me create a new package in Eclipse for us. So new class, and let's go ahead and inheritance. I probably brutally misspelled that somehow. And this is probably going to be hard to see for the people in the back, but so there we go. And automatically create our main method. Oh, really? Can I not do that? Because where is it? Where is it duplicated? Type animal is already defined in. Hold on a sec. I think it's because. Oh, it's because you don't want me to. That's frustrating. You know what? I'll burn it all down. That's great. Yep, got it. So, sorry, I'm working in the wrong library. Again, I've tried to keep last semester's code around so that we would have it as a reference, but if I have to burn it, then I have to burn it. So new, let me just try one more thing. Animal. There we go. Okay, there was in a completely different source file now, so we can use that. Great. So we're going to start this class by basically reminding us of what an object and what a class is. So what are objects and classes? Anybody? No? Yes?
The class is like a blueprint for the object.
That's exactly right.
Instance of the class.
Yeah, in an instance, yeah. So basically, a class basically is a blueprint for Java or a programming language. It tells you how to build a particular instance of a class. So that's what we call it when we actually build an object. It's an instance of a class. Why do we use that term instance? I don't know, but you know, if you have we have an animal class here, right? And this is going to be used as a blueprint for building animals, right? So a class dictates two things, broadly, and one is, some kind of data about it, and some kind of behavior. So if you want to put it broadly, it's a bunch of maybe nouns and adjectives about it, right? And the behavior is the verbs, right? The things it can do, right? So what are things that define an animal? So let's a few simple things, right? Color, okay. Since I don't want to create a color data type, I'm just going to be lazy and use strings to define my colors. I like giving animals names. Okay. What other kind of things are common? Yes. Size, yeah. So we could do this by length. We can do this by, size is a bit abstract, but that's fine. I'm going to go ahead and do size because that's easy enough. We'll use that. This is pretty, I like this so far. We're going to just, again, I'm going to keep it simple here. So we're going to go with color name, color, and size. And I'm going to put name up here because I tend to find name being a bit more important. And so what are things that most animals do? Things that most animals do, let's see, yep, they eat, so they sleep as well, public, so let's go ahead and create some instance methods for it. Instance versus static methods, remember, instance methods are individual actions that a object can, that like an instance of the class can perform. So each animal can do their own thing. Whereas the static method, that's something that that doesn't require any instance of a class. It's just an action that just happens of in itself. So we'll review that if we have to. So public, and we're going to make these really simple. So public void eat, string, what is it going to eat? String thing, right? System.out.println this dot name. I'll learn how to type one of these days. It's also a new computer for me, so I'm getting used to the keyboard. String.name. And this is an animal, so we don't know what kind of animal it is. You know, some animals have really interesting ways of eating, like starfish. You know, so we're just going to go and make this as generic as possible. This dot name generically chomps. Sorry, generically noms plus thing. Okay. All right. So, noms thing, and why don't we make it a complete sentence as well? Period. Okay. And I want to keep it simple rather than doing sleep, which is perfectly well. We can do sleep as well. Public void sleep. System.out.println this dot name plus goes, and let's just hold down the Z key, right? Might as well have fun with this, okay? And public void move, right? Most animals need to move. So system.out.println this dot name plus move. Okay, and a couple things going on over here, right? Remember, these are methods that don't have a return type. Why? Because I'm trying to keep this as simple as possible so that I can just call the methods and they'll work. Right, and remember, we can take in any kind of parameter we want in our methods, and we can take in any number of them. Here, I'm just specifying 1 and then 0 parameters and 0 parameters over here. All right. For our data, I mean, there is something I should do to my data to solve this, right? What I should do is I should make these things private, right? Right? And why is that? Yes. Yeah, so no one can change it. Basically, this is called encapsulation, this idea of public and private stuff. And the idea here is pretty simple. We want to be able to when we create something, we only want people to be able to access it the way we say them to access it. Like when we eat stuff, we only want things to go in through our mouth, right? My little less than 1-year-old son, he once tried to give me something and he just was stabbing it at my stomach, and I'm like trying to tell him it doesn't work that way. It's got to go through the mouth. You know, the stomach's private. This is public. You know, so he's got to. So you know but this is the entire idea here. We want basically things to be only accessible by the way we specify it. So our name, we don't want somebody to change it. Once we create a name, we want to be able to. We probably want it set in stone once it's created. Same with the color and same with the size. So these things are private. That means that once they're created, they're created. And again, for simplicity's sake, I'm probably just going to focus on name. Okay? I'm just really going to focus on name. It's more of a brainstorming exercise with all the other stuff. So public. So a constructor looks like a special method, right? You remember that. And the special method takes the form of just an access modifier, right? Public animal. And then we can give it parameters if we want. Okay, let's assume we don't give it parameters. We say that maybe this is the default behavior. We don't. Now you get this for free if you remember, right? This is if you don't define a constructor by default. If you don't define a constructor, right, by default Java automatically gives you one, and it kind of looks like this, right? I say kind of because there's also this super call there as well. And everybody learned about super or no? Or super new? Okay, super new. All right. So we will. I'll go over super. Don't worry. But it kind of looks like this, and basically, as far as you've learned so far, all this stuff just gets set. What this will do is it will say, okay, he hasn't given me a default value for name, so I'll just say name is equal to null, color is equal to null. I'm just basically going to give everything a 0 value. For objects, that's null, and for the integer, that's 0, right? So, but if, say, I do want to set up a generic name, I'll say this.name is equal to, maybe I'll say this.name is equal to Andrew, because might as well use my name and not pick on any student in particular, right? So, and this.color is equal to red, okay? And then maybe this dot size is equal to 3 or something, right? We can set up these parameters. And we can use, we don't need the this in front of there. I just do that as a matter of habit, right? But this means this objects, right? So this dot name means this animal's name, this animal's color, this animal's size, right? I don't need it. Here it's implicit, right? And you'll notice that over here, when in this method over here, string thing is, Eclipse goes ahead and colors thing a light brownish color and the name a bluish color. And it uses the blue to basically tell me that this is an instance variable and that this is a local variable, right? This is a good way to tell. And this becomes apparent if we do want to set up the name. If we do want to create the name on the fly when we create this class and not set it to Andrew. So string, string name. And here we're creating a local variable called name. So I can't just go name is equal to name, right? Because then I'm setting a variable equal to itself, right? It's giving me a small warning over here. Let's see what it says. The assignment to variable name has no effect, right? Because we're setting the thing to itself, right? How do I tell them apart? Well, I'm saying this guy's name is equal to name. Now, you might find that's confusing, but it makes sense after you've done it a while, and this is basically the way to do it that's kind of done. I mean, it's just, you see it a lot in code, in other people's code. So I'm saying, and why is that? Why do I name these things the same thing? Doesn't that seem like it could be confusing? Well, if you're consistent about using this, right, then when you're if you've got like 10 variables here, which I don't suggest doing, but if you do have 10 variables here, it makes it very easy to match them up if they have the same names, right? I can match name to name, color to color, size to size pretty easily, okay? This dot color is equal to, honestly, so I can just copy this stuff over here, okay? Okay, honestly though, there's a bit of repeated code over here, right? So how many of you learned that constructors can call other constructors? Yep. So if you were in my class, you should have learned it. But so we can totally call other constructors by using the this keyword again. So this has a whole lot of meanings. So this means this object. This dot means let's do this, get this variable, or this guy's method. But if you use it with parentheses, and I'll show you the end, and I'll run this for you to prove that this works now that we have a working example. This dot name means call the constructor that takes in one string parameter and run it, right? See, it says I'm being lazy. I don't want to redo all this work, right? I don't want to have to write all those lines because it might not be 3 lines. It might be something more like 100 lines, right? So it says the only thing that's changed is the name, right? So all I'm going to do is provide Andrew if you don't provide anything, and that's going to be sent to this parameter. So let's go ahead and create a few animals to show how that works. So public static void main, right? And so these are the magical words to run a program, right? Sorry, args. See, this is what happens when I talk and type at the same time. Okay, so let me go ahead and add some spaces so that we can see it at the top. Okay, let's create a new animal. So remember, animal A is equal to new animal. That's how you create a new object. And if we want to give it the name Eddie, we can do it like that. Okay, and so now we can do a dot. So let's go ahead and do a dot move and system.out.println a dot size, right? So we're going to print out his name. So, right, we're creating this animal, right? We're going to do a dot move. We're going to ask him to move, and then we're going to print out his size. So let's run this. Eddie moved. So let me go ahead and add a space there. Eddie moved generically, and 3. Oh, sorry. And 3. So that was our move method and our size. So, right, providing Eddie as the name, that set this, right, this sent Eddie over here, and we set Eddie to the name and set the color to red and the size to 3. I mean, I don't have to prove to you that the color should be red. If I don't have a parameter, though, what happens? So what's going to happen is that we'll say Andrew moved generically. And why does it do that? Probably turn that into a sentence too. So run. So how did it do that? And so all it had was this Andrew. It didn't have anything about setting the size to 3, right? So how did it set the size to 3? Well, this Andrew, a useful tool is control-click on IDEs. That allows you to go into something and see where it brings you. Brings me to this one. It provides Andrew as an argument to this constructor. So this constructor, the constructor with no arguments calls the constructor with 1 string argument. So that's a pretty useful tool. It's not going to crop up too often, but you should recognize it. I'm just trying to fill in the gaps of what you might have missed in 1068, essentially. Okay, because at the end of the day, this wasn't too important as you know, the things were a lot more important, such as, do you know how to actually write a class definition, and do you know actually how to write methods and use logic and stuff. And that was the main thing we were trying to test. And so if you missed this kind of stuff, it's okay. Don't feel bad about it, because that wasn't, these language-specific things weren't exactly what we were looking for. We were looking for, hey, do you know how to iterate over stuff? Do you know how to use for loops correctly? Do you know how logic works? Those kind of stuff. So a dot sleep, right? Okay. Fantastic. So everybody following so far? Great. So this is an animal. It's fairly generic. So I want to get a bit more. So the nice thing though about Java is that it's an object-oriented programming language, which means that I can and there's 3 features in object-oriented programming language. First one, encapsulation. The idea that basically that people can only access methods and methods and variables if we want them to. We can hide them from other people. Why do we want to hide things? Well, because our programs are about to become rather complex. Okay? And we want to make our programs as simple to use as for other developers to use as possible. They don't need to understand how something works. Like when you call math.square root to calculate the square root, you don't need to know how the square root is calculated. You just need to know that it gives you the square root with some reasonable approximation that's actually quite good. You don't have to know anything about Newton's method, okay? Which is a nice math hack that you can do to approximate stuff. You just run the square root method, okay? Similarly, you don't need to know that basically that these are internal variables in here. You just need to know how to create it and how to call this animal. Okay, the second key is inheritance, which says that if I want to make other types of animals, right, I can reuse the animal code to make other types of animals, more specific types of animals, right? So I'm going to go and go with reptiles because I happen to like herps. Reptiles and amphibians, herps. So we're going to go with the reptile class. Okay. Now the idea here is that basically I can reuse all the code inside of I can reuse all the code essentially inside of animal just by going extends animal, right? And now I'm saying that a reptile is an animal, right? And as such, it has a name. It has a so the reptile does have a name. It has a color, it has a size, and it can do all the other things that an animal does. So just to do it, I'm going to write my own main method here, public static void main. And again, if you're worried about getting this code down and missing something, this is part of the reason why I record this lecture online, and also part of the reason why I post this stuff on GitHub. Okay. Also, as a reminder, actually, there's probably one thing in the syllabus I do want to mention right now because I do record the lectures. If you do happen to be sick, please don't show up to my class. I don't want what you have. So if you happen to be sick, just stay home and watch the lecture. There will be quizzes, pop quizzes every so often. But if you miss one, that's not the end of the world. And if you need to make it up, well, we can work something out. It's not. I'd rather you be getting healthy rather than here struggling to stay awake. And wondering why everything hurts. All right, so let's go ahead and prove to you that a reptile is basically an animal. So I'm going to go ahead and say reptile r is equal to new reptile. Okay, r.move. Okay, so it says Andrew moved generically. Just making sure we did run this. So just to make sure we're not. Yeah, so we did run this because the other one would have printed out a whole bunch of other stuff. R.move. So R.move. Sorry, not move. Let's go with eat. Okay, the bug. Let's go with that. So Andrew generically noms the bug. Don't need a second period in there, okay? So you just tell it what to eat, and it eats it. Great. So, it's got the move method and the eat method that its parent does, right? So, right, we see that animal is a reptile. Sorry, reptile is an animal, and an animal is an object. So one thing to note is that you're always extending a class, even if you don't tell it to, okay? You can only ever extend one class. Why can you only ever extend one class, by the way? Anybody, did you happen to learn that? So there's a couple correct answers. The first is because that's the way Java works. You can only extend one class in Java. But the reason for that is that we could, let me see, so just remember, let's see, so this should, so, sorry? Yeah, if you have variables or even better methods. So suppose we have a class A, right? Suppose, let's just prove it by counterexample. Suppose you had a class called A, right? And A had a method called foo inside of it, okay? Nothing too fancy there. B also has a method called foo. Suppose C extends both A and B, okay? So when we call foo, how do we know which foo method to use, right? Do we use A's or do we use B's? So there's two ways to resolve this conflict. The first way is to not let this conflict happen in the first place, which is what Java chooses. So you can only extend one class. The other way to do this is maybe to set up some kind of like rule that if the phrase for this is C extends A comma B, then because A is first, it will run A's who first. And if it was B comma A, it'll run B's first, right? So that's another possible way to solve that. That's not how Java solves that, but that's another possible way to solve that. Okay? So as a result, we just only can extend one class. So if you're not extending anything, though, you are kinda, well, you totally are actually. There's an implicit extends object. And in that way, everything is an object. So a reptile is an animal, and because animals are objects, a reptile is also an object, right? You know, all A's are B's and all B's are C, therefore all A's are C's, for that old logic thing. So it's an animal, it gets all the things that, and it has all the things an animal can do. Let's go ahead and, try to, let's go ahead and give, but I don't want it to be called Andrew, it's a reptile, so I should maybe call it Ralph. Okay, so here's where we start getting into our first bit of issues. Errors exist, why? Well, I totally know why, but I'm just, so just play along with me. Okay, it says the constructor is undefined. But I mean, animal has this constructor, right? And if I get all the things that my parents have, I should get my constructors. And that's the key there, because you don't actually get everything your parents have. The exception is you don't get your parents' constructors, right? Right? That's the exception to the rule. You don't get your parents' constructors. So when you inherit something, you don't get your parents' constructors, which is something you'll totally forget about when programming until you run into this error, right? Which is something that I totally did until I had to teach this class. So it was just one of those little rules of Java. So, but then you might go, wait a second though, this constructor worked, right? And it worked the exact same way that this one did. It set up Andrew to be the name, and it set, well, let's see, did it set r.size equal to 3? So let's go ahead and print that out. So we're about to get into like into a bunch of errors now. Like, why isn't this working the way we expect it to? Aside from the fact that I can't type. Again, new computer, sorry. I'm going to use that as my excuse for a while. So it says, wait, there's an error. R.size is invisible. So an animal's not visible? All right, so we've got two errors. So we've got first problem. We don't inherit our constructors, but somehow this one worked. Okay. And the second one, which is I'm going to solve first, which is a bit easier to solve, is that apparently we can't see our own size, even though we totally have a size, right? Because we had a name, it printed out our name when we did r.move and r.eat. So what's going on here is that when we say private, we really do mean private. We mean nobody else can see it but animal, and that includes all my children, right? All my subclasses. So if you are a subclass of animal, you can't see the variable name because it's private, right? You're another class. You can't see other classes' private variables, which is kind of inconvenient for doing inheritance, right? So as a result, there is a third keyword for this kind of situation where we do want our subclasses to be able to see our variables, but no one else, just our subclasses. Okay, we're keeping it just to our subclasses. So protected. And that's kind of like private, okay? It's kind of like private, except that it also lets me see my subclasses see it. It's actually exactly like private, except where this will now work, right? So Andrew not move generically, sorry. Andrew generically noms the bug 3. Okay. So, all right. So the first thing was that private means private. So the solution to the second problem was private means private. So we can solve that by making everything protected. And that means if I'm not a member of this class, I can't reach in still, right? But all my subclasses who will probably need that to access that data, they can access that data. All right. So what about this one? Why does this constructor work? All right. I mean, will it still work if I do this? Public reptile. Right? What's going on here, right? I just said it. I said don't do anything, and it did something. It set the name to Andrew, and it set this to 3, the size to 3. All right. What about what if I do this? This dot name is equal to Ralph. Right? So this animal's name is equal to Ralph. I can access name now because it's protected, right? So now subclasses can access the name, right? So let's see this. So Ralph moves generically, but it still sets it to 3. I'm not telling it to set the size to 3 anywhere. Where's that coming in? Anybody know? So this is where the super keyword comes in, okay? So what happens is that when you have a constructor, there's an implicit super call. What is super? Super is let me call my parent's constructor and do everything my parent's constructor did first. So whenever you write a class, this is something that Java just throws in for free, which can sometimes lead to confusion, but it's actually extremely helpful, right? So here, let's go ahead and now go through this. Notice that with the super call in here, it doesn't change anything, right? It goes exactly the same way. So let's control click on super. Super is basically saying, let me call my parents thing, okay? So if it was super dot variable, like I can totally do I can totally do super, let's see, can I do super dot color? Somebody's in trouble. No, it's mostly a method, so it's a method, so just, that was silly of me. Okay, super, let's click on it. It brings me to my parent's constructor. And my parent's constructor brings me, says pass Andrew as a parameter to this constructor. So we had a constructor call a constructor, right? So that's a bit weird, but nothing we can't follow, right? It's just kind of a flow chart going here. So actually, can I do this in one line now? Because my parent, right, they have 2 constructors, right? So I can just pass this to my parent's constructor, which takes in a single variable, which takes in a variable. So now, Ralph moves generically. Ralph generically noms the bug 3. Okay, what if I don't want it to be 3? Well, the super call always has to come first. So if I try to do this dot size is equal to 5, notice it gives me an error. It says you can't do that if a super call occurs, it's got to be the very first thing. And that makes sense. You want to do all the things your parent set up, right? We assume that your parent knows way more about what it needs to set up than you. So you set up all the stuff. So you run all of your parents' code first, and then you make the changes about what's different. So, Ralph, and then this dot name is equal to not this dot name, but this dot size is equal to 5. Okay. And again, we still can't do this where new reptile is equal to Eddie because again, we did not get our parent's constructor, the other constructor that takes in a single variable. So let's go ahead and make our own constructor there. So a lot of times when you create your own new code, a lot of times that's a subclass. All you have to do some of the time is just modify the constructor if you want to change how the variables are set up. So, and again, let's just do this. So this error is because, of course, I can't have 2 constructors of the same name. So just go string name and super name. And again, this is just going to call my parent's constructor. Now, a lot of this code is easy enough that if you're using an IDE or anything that's got a bit of extra clever scripts in it, I mean, like, so if this is not your first rodeo with programming or with data structures, like you already know a lot of data structures and a lot of what I'm already going over. If you don't already know Vim or Emacs, I'd suggest going ahead and taking time to learn Vim and Emacs, which are not programming languages, except they totally have programming languages built into them, but they are really powerful text editors. So if you're feeling pretty comfortable with this stuff, take this weekend to spend a couple hours learning to use Vim or Emacs, because that will kind of change your life. New mouse too. So all right. Oh, did I ever switch back? Uh-oh, I don't think I ever switched. See, that was the problem. Okay, obviously I need to do it. Okay. So obviously I can't be trusted because I forgot to switch back to the window view over here. So it was just me droning on while I was typing on the keyboard and nobody could see it. So obviously I can't be trusted with that. So I'm afraid that we're going to just have to go with the original solution I have of that. So, okay. So obviously since I can't be trusted, I'll leave it like in this format for right now, and then I'll switch it when I get home so that basically, yeah, I'll switch this around. Okay. Well, that's embarrassing, but hey, it's the first time I'm doing this setup, so a couple of hiccups were bound to happen. Okay, so all right, so now this is the code that we created. So let's go ahead and, so there's a bit of a issue like from a story-wise perspective here, right? Eddie is generically nomming the bug, and lizards, they more chomp. So what we're going to do is override our parent's behavior. So public void eat. So if you remember, overriding and overloading. Overloading meant you could pass in, you could create a method that has a different signature, meaning it has the same name, but it also has more variables in it. But if you're a child class, you can override your parent's method, right? This means that basically, rather than generically eating something, well, lizards, they more chomp on. They're more of an ambush kind of predator, so they'll chomp on something. System.out.println this dot name plus chomped thing okay, so now if we do this and run it, got to remember to concatenate over here, run this. Eddie moved generically, Eddie chomped the bug. All right, so reptile r is equal to new reptile, r.move, r.eat the bug. So now we have a way for this lizard to eat it. And now if we create an animal A over here, animal A is equal to a new animal. So I'm going to speed up. A dot eat the lettuce. Okay, he's going to, so Eddie chomped the bug, Andrew generically noms the lettuce. Okay, right? We moved from being, so he still moves, Eddie still moves, the reptile Eddie still moves generically, but he now has a more specific method, right? And this is the point of overriding. This is to give give us a more specific behavior, right? We're giving a more specific behavior. So let's go ahead and just follow this all the way down. We're going to go ahead and make ourselves a lizard. And right, we don't have to have just one animal. So let's go ahead and see how much help this is going to be. So create a public stack void main for me. Constructors for my superclass. My superclass is going to be reptile. Okay, and my let's see, do I have the right reptile? Superclass. Because I do this example a lot. There we go. Inheritance.reptile, and then finish. So there we go. So that already generated a lot of stuff for me. And then I'm also going to do this one more time for SNEC. Okay, so set this up for, so a SNEC's parent is also a reptile. And if you are unfamiliar with this meme, then tonight your life will now be filled with much joy. So, all right. So these are, so we have a so our hierarchy, our type hierarchy now looks like this, where we have an object. I mean, I'm probably going to have to figure out how to set the GUI over here to be a bit bigger, because even for you guys, that's probably pretty small, right? So first off, can everybody see the code? Can everybody in the back see the code just fine, or do I need to up the text size? It's no problem for me to up this from 14 to 16. Everybody good on this text size? Okay. This size. So raise your hand if this is really tough for you to see. Right, so already in the second row, so I'll have to update this. So I'll just read it out for you. So animal is a descendant of object, reptile is a descendant of animal, and lizard and snake are descendants of reptile. Fairly straightforward. Okay, so let's go ahead and fill this out, right? So lizard, we're just going to go ahead and say, if you're a lizard, your generic name is Lizzie. So this dot name is equal to Lizzie. And right, there's the implicit supercall, which sets Lizzie's color to red and her size to 3. But then and her name initially will be Andrew, right? This will be interesting just to prove this. Print line this dot name, right? Okay. So and then this one has what we already want, which is to call our parent's constructor, right? So let's go ahead and say lizard L is equal to a new lizard, right? And so if we run this, it's going to be Ralph Lizzie, right? Because why Ralph? Well, because I said Andrew, but that's because I wasn't thinking ahead enough, right? Print out this dot name. It's going to, well, the first thing that runs is super, right? So call super, and super is an animal. It's actually reptile, which calls this super Ralph, so it sets the name to Ralph, right? And once that's done, we go back to reptile, set the size equal to 5, and now lizard prints out name, sets it to lizard, right? Normally it doesn't get nearly this complicated, and you shouldn't have to worry about any of this stuff, right? But that's just what happens when you do inheritance with constructors, which is that you execute all your parents' constructors, and then you get to your own constructor. So this dot name is equal to Lizzie, and that's really all we need to do for that. And let's go ahead and say, let's go ahead and override both the methods this time. Public void. There was no need to override sleep because everybody goes Z when they sleep. I mean, maybe except for sharks, I'm not sure. So public void eat. Okay. System.out.println. This dot name dot pounces on, oh right, and we need, here we were overloading a method, right? Because we already had, I was accidentally overloading and not overriding, because remember we had an eat method already that exists, but it took in an argument, right? So if we want to override, we have to provide the same argument. Let's do this. On. Thing. Okay, awesome. So we're gonna pounce on the thing, and then lizards as a whole, they just, if you look at lizards, doesn't really matter how big they are, from the lowly chameleon to the and gecko to the giant Komodo dragon, they all scurry, in my opinion. So we'll say that this dot name scurried away. Okay, so L dot right? And we can do similar things for snake, where where basically a snake we could override it to slither. I was just doing that to show you that basically that you can have one thing inherit, one class like reptile can be inherited by multiple animals. Okay, so this is where we're going to start getting into our third aspect, which is polymorphism. So L.eat. See, I named it eat. It should be move. I mean, I'd blame it on the lateness of the day, but I don't want you to use that excuse, so I can't. So L.move, Lizzie scurried away. Okay, great. So the great thing about inheritance, though, besides being able to reuse code, is how it works with polymorphism, which is many forms. I believe it's Greek, but hopefully we're not mixing and matching Greek and Latin, so I think it's pure Greek. So the idea here is that we can treat lizards as animals when we need them to be treated as animals, and we can treat reptiles as animals if we need them to be treated as animals. And so an example of this is that, right, and again, I'm going to switch away to, so I'm just going to put this up as a reminder to me to switch back to this. So the idea here is, great, I lost my train of thought. We have, so we have let's go ahead and consider our variables to be a box, right? So if I say animal A, right, this creates a new box, right? It's an empty box, kind of, and it's labeled, and on it is labeled animal, right? Which says that this is an animal box, and we put animals in this box. Right? That makes sense to everybody? So, so when we do the following assignment statement, like new animal, what we think abstractly to ourselves at the high level is that we're creating a new animal and we're putting it in this box for storage, right? So we're creating a new animal and we're putting it in, and it will be named Andrew because that was the generic call for it. So we're going to put Andrew in this box, labeled animal. Okay? Okay, what really happens, of course, if you remember, is that we don't actually store the animal in here. What really happens is that we put a memory location of some kind, like 0x25A4, right? Which tells Java where we can find the animal, right? What actually gets stored in here is a reference for an object, right? And that's just somewhere in memory. And why is that? It just has to do with memory management and making memory management easier. When we pass methods and when we pass objects into a method, it makes it easier if we just copy the references rather than copying the entire maybe 1 gigabyte object around. So, so we're putting an animal, but for our purposes for this discussion, remember that what gets stored in here is a memory location. But we can conveniently think of it as we're taking this and we're storing this in here. We're taking Andrew and we're storing him in this animal box. So as a result, it makes sense that I can do something like this. New lizard, right? This will be, and I'll show you on the computer in a second, this is a valid statement. Animal A is equal to a new lizard, right? Because we're creating a new lizard and we're storing the memory location of it. We're storing it in the box labeled animal. Right? And this is okay because a lizard is an animal, right? A lizard is a reptile and a reptile is an animal, right? So there's a reason I did the animal example. It's because now as opposed to going to foos, bas, and bars, this actually makes logical, consistent sense. We can put lizards in animal boxes, right? But it doesn't work the other way around, right? So caveat, it doesn't work like this. It's not going to work like this. Lizard L is equal to a new animal, Ed the elephant. So it should be well known to you by this point that elephants are, by a certain age, bigger than the biggest lizard, right? You cannot fit any animal into a lizard box, right? There are many animals that are bigger than lizards. It just won't fit. And this is from our story perspective, right? Right? This, it just won't fit. So that's our story perspective. From our coding perspective, we don't know that the animal right? This is a box labeled for lizard, right? This is the variable. Says, hey, this variable holds a lizard inside of it, and this animal may not necessarily be a lizard. It might one day be, but it's not, right? It's an animal. It's a much more generic thing, right? You can't take something more generic and put it into something more specific, right? You can't. That makes sense to everybody. You can't take an animal and store it into a lizard. You can't take a reptile, store it into a lizard. But it works the other way around because we can take something and put it into a more abstract container. That makes sense? So let's see some examples, and then let's go ahead and look at why in the world would we want this in the first place? Okay, so not enough for me to teach you that this is a feature. You got to understand why in the world this is a feature and why it's so useful. Okay, so let's go ahead and switch back. This works now. So if I remember to, okay, so this works, and let's just double check to make sure that I'm not recording my wonderful face again. It's not actually that great, but okay, yep, so it is actually going and recording everything that I actually wanted to. Awesome. So lizard L is equal to new lizard. So we can instead say animal A is equal to a new lizard. And then let's go ahead and, rather than moving right now, dot out dot print line this dot name, and you're going to see that the name is also not this a dot name, right? So it's going to be Lizzie, and that makes sense because we're creating a lizard, right? We open the box, we discover a lizard, and its name is Lizzie, right? Because that makes right. This constructor ran, the lizard constructor ran, which called the reptile constructor, which called the animal constructor. That makes sense that its name is Lizzie. Does this confuse anybody that its name is Lizzie? Right? Okay, awesome. So this is the part where you may have found this on your final exam, and it might have been a bit confusing. And that's okay because it took me, you were probably dead tired from studying and possibly had a cold or something. It was this final exam season is brutal, and I'm really sorry about that. It's just the way it is. So lizard. So let's go ahead and do lizard. So here's the question that we love to ask, and we love asking multiple variations of this. So lizard L is equal to new lizard. Animal A is equal to new lizard, right? So now if I do a.move, the question is, what gets printed out? Is it this dot name scurried away? Is it Lizzie scurried away? Is it, or is it going to be this dot name Lizzie moved generically? So is it going to be Lizzie moved scurried away, or Lizzie moved generically? That's your instinct, and that's the instinct that you would get. But that's, believe it or not useful if it was to do that. It's actually what actually happens is a bit more complicated. It goes with Lizzie scurried away. And that's weird. And you think rightly so, by the way. You think rightly so. That's weird. It was an animal, right? We put a lizard in the animal box, and we said, hey, animal, move. So why didn't it move like a lizard? Why didn't it move like a lizard? And the reason for this is actually, it does make sense when I actually go through this example, right? And this is why I like thinking about it in terms of boxes. Well, I open up the box, right, and discover what's inside, right? A lot of things can happen in here, and we might forget what's actually inside there, right? So we open up the box and discover, to our surprise, that this animal box has a lizard in it, right? So we take the lizard and we ask it to move. It's not going to move generically. It's going to move like a lizard, right? Because the lizard was in the box, right? It just happened to be, the box just happened to say this box holds any type of animal. It could be a lizard, it could be a reptile, it could be a snake, it could be an elephant, it could be a zebra, any type of animal. Could even be a generic animal, right? Any type of animal, right? So that's kind of useful. So if I do a.eat food, right, it's going to say it pounces on the food, right? So what happens is that it uses the most well-defined, the most specific operation. Basically, it takes out the animal and the animal out of the box and it looks at basically, okay, it is a lizard. So what is the behavior that lizards do? Lizards move, they eat, they have their own move and their own eat behavior. What about sleep, right? We forgot about sleep. Well, lizards gets its behavior, well, it doesn't have a sleep behavior. Really, what's going on here? I was really pleased with this mouse, and now less so. Okay. So so it asks, okay, you're a lizard. What's your sleep behavior? And he goes, I don't know, ask my parent. And it goes, well, I don't know, ask my parent. It's got to be there somewhere because it's compiled. And he goes, animal has a sleep behavior, so we'll run that. So if we can't find it, we basically follow the chain up. Okay? So it goes and calls its parent's method. So, okay, that just seems unnecessarily confusing. Why are we doing this? Why is this polymorphism in here except to confuse poor students, right? I mean, that does seem like that does seem the sole purpose of it right now. Well, suppose you want to create, so now we can actually start getting into data structures, which is basically we want to be able to organize data, okay? We want to be able to organize it together in a convenient manner. So it's useful that if we want to take a collection of animals, that's a term we'll be throwing around, and Java has a specific meaning for it, but you can kind of just grok what it means, just like you can grok what grok means. So you can intuit that basically that a collection in Java is just a group of things. So an array is one of those. So let's go ahead and make an animal array called a zoo. Okay, equal to a new animal. And don't feel bad if you forget how to create new arrays on the fly like this. I had to look it up every time at the beginning of the semester, like for the first 3 years I was programming, like because I could never remember for the first time. It was real embarrassing. But animal zoo is equal to new animal, and we have 10, let's call them boxes, or cages, for our animals. We have 10 slots for them, labeled 0 through 9. So in our first slot, we will have zoo 0 is equal to a new animal. Our second slot, zoo sub 1 is equal to new animal. Let's call him Fred the Frog. Okay. Zoo 2 is equal to new reptile, right? So I'm creating an array of all different types of animals. So this is where it's useful, where I have a collection of animals and I don't necessarily know what type they're going to be, but I can store any kind of animal I want, right? So everybody see kind of how that can be kind of useful. Zoo is equal to a new lizard. Zoo 4 is equal to a new... You know what? I think I'll just leave it there, and I'll go ahead and reduce this to having only 5 slots. Okay? So now let's go ahead and iterate and feed all these animals. Okay? So for int I is equal to 0, I is less than zoo.length, right? So remember, it's it's dot length for an array without parentheses. But if it's a string, it's dot length with parentheses. And then if it's a collection, which is what we're going to be dealing with this entire semester, it's going to be dot size with parentheses. Okay. Why? Because a collection might not actually have a length, but it will have a size. Okay. So I++. Okay. So zoo dot. So now we're going to take the ith animal, and we are going to tell it to eat not a human. Okay. Okay, so now if we print, so now if we go through all these things, Andrew generically, Nom's not a human. Fred the frog generically, Nom's not a human. Ralph Chump not a human, right? So each of these now are going through generic, like here's the animal method, here's the animal method, here's the reptile method, here's the lizard method. This one is actually, because it's a snake method, but I didn't define those methods, right? So it just falls back on reptile because that was the last defined. So it goes, I don't know what, so I know I have an eat method, but I don't have it defined, so I'm going to ask my parent. And the parent goes, here you go, here's your eat method, right? Right, we only have to override it if we want to. So that's one way to iterate over a collection like that. The other way to iterate over a collection, and you can only do this if you don't care about the indices, right? In this case, we just want to feed everything, right? So we don't really care about like what index things are at. So if you don't care about what index everything is at, you can use something called a for each loop, okay? And I'll write it and then I'm going to read it to you. So for each animal A, I already have an A. Each animal in zoo. So it looks a bit weird. It looks shorter, a bit more concise, but it does look a bit weird. So this is a for each loop. Okay, you can use it on anything that has an iterator, which arrays do. So pretty much everything that we're going to be building over this semester. And the way it reads is that for each, right? So first off, you know it's a for each loop because it doesn't have the three statements inside of it. It doesn't have the semicolon statement. It doesn't have, the initialization, the condition, and then the update statement, right? It just has animal. It just has a colon. So this says for every single animal inside of this collection. So for every animal inside the zoo. And the type over here needs to match whatever type the collection holds, right? So if it's a collection of just generic objects, it would be objects. If it's a collection of integers, it would need to be ints, right? So, and now we can do it rather than using indices. We would just say animal dot eat grub. Okay, so now we go through this and it runs. Okay, so that's the nice part about a for each loop. Okay, and that's pretty useful. All right. So that should be new to some of you. Why don't we teach this to begin with? Well, because you need to use for loops before arrays, right? For loops are useful for more than just arrays. And a lot of times when we do stuff in arrays, a lot of times we want to set values inside the array, and you can't do this with that, right? This won't work. This won't change any of the... This animal is just a copy of what's ever in there, and if you try to modify... or it's a reference to it. So if you try to say animal is equal to the new something, it's not going to change anything in the actual array itself. Okay. All right, so it is 6:45. So we still got plenty of time left, but I've been talking for a while. So why don't we go ahead and take a short break? And I'm going to say we're done with most of Chapter 1. Hooray. So, however, Chapter 2 will take basically the first 4 weeks of class. So it's because now Chapter 2 is going to be like the hardest thing not the hardest thing, but basically the difficulty peaks by basically week 4 in this class. So if you can get through week 4 or 5 in the first exam, you're pretty much golden. So basically you'll know basically very well with very soon, like, how, am I going to struggle in this class? It's not going to say like it gets easier. It's just that basically that because the concepts are new here and the type of thinking you're going to have to do is so new, it's just going to feel like the hardest thing. So once you get up over that hump, it's going to be fairly straightforward. All right, so I'm going to go ahead and stop this recording, and I'll pick it up when we get back in, let's say, 6:55.